Welcome back to this course entitled Elementary Electrochemistry. In the previous couple of videos, I have shown how to prepare a primary standard oxalic acid solution for standardization of NaOH, and then we have shown you how to do standardization of NaOH, and I am going to share these readings with you later. So now we are here ready with the setup with a pH conductivity meter. It's pH cum conductivity meter, which you can see in your screen. This pH conductivity meter has two options, with a pH electrode which will measure the EMF change inside the solution and convert it into the corresponding value of pH is now connected. And this pH conductivity meter, when it is running in the pH mode, we need to do a calibration. So before starting this experiment, I have calibrated it with three buffer solutions: pH 4, pH 7, and then one can check whether the calibration is correct or not with a pH 9 buffer. So at the moment, what we have in the beaker here is a pH 4 buffer, and in the meter you can read that it is showing 3.99 as pH. So that is indicating that the pH meter is calibrated. So just to make sure whether when everything is working fine, I want to check the pH of this pH 9 buffer, how it reads using this pH meter. So I should take about 40 to 50 ml of the buffer solution so that the electrode completely dips inside this solution, and before that we should wipe out the electrode after removing it from pH 4 buffer. One should clear the electrode completely so that there is no solution of pH 4 sticking to it, and then we carefully insert the electrode in pH 9 buffer. You can see that the reading on the meter was fluctuating when it was in air, and now it is going to stabilize and it shows a reading which is very close to 9. It may take a while to stabilize it to 9 or about 9.15, which it is showing. So with this, I think we are ready to start our experiment. So I am transferring back the pH 4 buffer, which we don't need anymore. Now we are ready for the estimation of approximately n by 100 HCl that we have here. We do not know the exact strength, so we will use this n by 100 solution for the potentiometric titration using n by 10 NaOH solution. You see that there is a 1:10 ratio of HCl versus NaOH concentration, and we have discussed the reason for this in the class. Here what will happen is, if you take 10 ml of n by 100 HCl and we will have to add little amount of water so that the electrode completely dips in water, then it will show us the pH of that solution, and then when we are titrating it with NaOH solution of about 10 times more concentration, so for 10 ml of HCl, the total volume increase will be approximately about 1 ml to 1.2 ml, and that will reduce the change in pH due to increase in volume of the solution. So in front of me I have now a 10 ml burette, which you can see here. This 10 ml burette is filled with n by 10 n by 10 NaOH. This n by 10 NaOH we will add dropwise to the solution of HCl, which will I am now going to take using a pipette. So this time I am using a different pipette pump, which you can see here in my hand. So we will use this different type of pipette pump to pipette out 10 ml of HCl. And we carefully take it only up to the mark, which indicates 10 ml. We have a mark here in the pipette. As you may be able to see, the mark is at this point here, which indicates that we have 10 ml solution in this pipette. So I will carefully transfer the entire solution to this beaker, in which we will do the estimation using the pH measurement method. Once again, we should just touch the bottom of this beaker with the tip of the pipette, and whatever small amount of acid is left behind is supposed to be left behind. So that does not is not included within the 10 ml that is calibrated for this pipette. So now what you can see is that the electrode cannot be dipped in such a small amount of liquid. So what we need is, we need to add some amount of water, making sure that the electrode completely dips. And we get the reading of pH as shown here, which you can see is, so without addition of any NaOH, our reading of pH is 2.73. Now what we need to do is, we need to very carefully add very small amounts of NaOH from the burette, and as I indicated, this particular burette, which is a 10 ml burette, can pour very small quantities like 0.01, which can show 0.02 ml of reading, or it can transfer 0.02 ml you can measure. So after addition of 0.02 ml, that is just about 2 drops, you can see that there is a small change in the pH. So I am noting down this reading as 0.2 and the reading is 2.68, right? So like that, I should be adding small quantities every time, about 0.2 ml each time, and shake it well so that we reach the equilibrium and the stable pH is read. So it is with 0.4 ml, the reading is 2.69. You must appreciate that this pH is not changing, because this is strong acid which is completely dissociated in solution, and hence the pH does not change with addition of NaOH significantly from the burette. So I am going to continue this addition of NaOH very little at a time, and every time I have added 0.2 ml, which means now I have added 0.6 ml and the reading is still 2.69. So like that, I should continue doing this addition for a long time, 0.2 ml at each step, till I see a sudden jump in pH. Now I have kept adding 2 drops each and continued taking the reading, and I have reached a reading of 0.6, which you can see from here. With 0.6, I am getting a pH of 2.96, which now means that the H plus ion is considerably consumed and the pH has increased a little. And if we continue like this, there will be a point when there will be a sudden jump in pH. Now I will again add up to 0.8. So now you can see by slow addition of 0.02 ml each time, I have now reached the reading of 0.8 ml, which you can see here. So with 0.8 ml of NaOH addition, we have reached a pH of 3.97, which you can see in the inset. Now I will add up to 0.9. Now I have reached a point where I have already added about 0.9 ml using this 10 ml micro burette, which is reading here. It is between 8 and 9, which you can probably see in your screen, and the pH that we have reached is 3.33. So what we can see is the pH is slowly increasing stepwise, but not increasing very sharply. So now I should add a little more and see at what volume of NaOH the pH suddenly starts to jump up. Now you can see that we have reached a point about 1 ml in this 10 ml burette, and the pH that we have reached is 3.57. So that indicates we are very close to the equivalence point. We have to be very careful at this point, and we should again continue adding 0.02 ml at a time and try to get the end point very accurately. So now I am continuing addition by 0.02 ml at a time. and we have reached 3.91, and like that, if we just add up to suppose now I have added 1.10 ml and the pH has jumped up to 4.33. With 1.12, the reading has come to 4.79. .14, the reading is 4.96. With 1.16, it has come to 5.21. With 1.18, it has come to 5.50, maybe 5.51 when it stabilizes. It takes a while to stabilize, so we should take the reading when it stabilizes the pH. Yeah, maybe 5.57. Then we add again another 0.02 ml and reach 1.2 ml, where the pH comes about 5.76. So it takes a while to stabilize. So with addition of 1.2 ml, the pH is 5.83. So now with 1.24 ml, the pH has come almost to the neutral pH of water. It is about 6.73. So I am expecting with one more drop, that is another 0.02 ml, this pH will jump beyond the neutral pH and it will become alkaline. And as I have indicated in the lecture, that we should continue addition of NaOH little more beyond the equivalence point, so that we can achieve a flat region once again, as there was a flat region at the beginning when we were adding NaOH in the early stage. So now what you can see is, with addition of 1.30 ml, the pH has jumped up to 8.64, as you can see in your screen, which essentially means we have crossed the equivalence point. We would need about 3 to 4 points beyond this for a good pH curve that I have shown you in the class by hand drawing. With this experiment, we can achieve that kind of curve as well. The experimental curve can be achieved. So with the addition of 1.32 ml of NaOH, we have reached a pH of 9.58. We need few more such readings till we reach a flat region. So with 1.34 ml of NaOH, we have reached pH of 10.01. We need 1 or 2 more readings. Since we have reached the point where we have crossed the equivalence point and we have reached pH of more than 10, so now I have added 0.06 ml of NaOH to reach 1.4 ml, and with 1.4 ml we see that pH has changed only from 10 to 10.25. So what you can see, that in the beginning the pH was not changing. Towards the equivalent point, the pH was changing slowly. Near the equivalence point, the pH changed drastically, close to 7, and then it has reached 8, 9 and 10, and now with addition of more amount of NaOH, the pH is not increasing significantly as it was doing when the equivalence point was reaching. So now I am adding 0.1 ml, that is reaching 1.5 ml. So by addition of another 0.1 ml, we have reached 1.5 ml, and you see that the pH has only increased by 0.25 and reached 10.5. So now what we see is the increase in pH is again very small, 0.25 for every about 0.1 ml addition. So we will take the last reading as 1.6 ml and then try to plot the entire reading using a graph paper and then determine the concentration of this HCl using the calibration or using the standardization process that we have done using oxalic acid. So now I have added 1.6 ml and the pH that we see it has increased only by 0.18 from 10.5 to 10.67, 10.68, 10.67 like that. So this is our last reading of this experiment, where you can now see the last bullet reading is shown here. It is 1.6. So what we have achieved here is we have done a titration of 10 ml of N by 100 HCl using N by 10 NaOH, which is technically 10 times stronger. So for 10 ml we would have required about 1 ml, and probably the NaOH is not exactly N by 10, which we will know from our calculation of standardization, and then we will be able to determine the concentration of HCl after we plot these data using a graph paper and then plot the data in terms of delta pH versus volume of NaOH, where you will see a sudden jump in that plot. So from that jump we will be able to calculate the concentration of HCl using this pH or potentiometric titration. So thank you very much for attending. We will continue similar experiments using acetic acid in the next class. Thank you.